This is the 9th problem on the Gravity and Uniform Circular Motion review paper. In this problem, a motorcycle has a constant speed of 25 meters per second as it passes over the top of a hill whose radius has a curvature of 126 meters. The mass of the motorcycle and driver is 342 kilograms. We're going to find the magnitude of the centripetal force acting on the motorcycle as well as the normal force acting on the motorcycle. Now this is vertical circular motion. It is moving in a circular path, just happens to be a vertical one and not a horizontal one in this problem. The forces acting on the motorcycle are gravity downward and the normal force pushing upward. We know that the speed is 25, the radius is 126, and the mass is 342. First thing and easiest thing to probably solve for is getting the centripetal force acting on the motorcycle, the total centripetal force. The equation I'm going to choose for that is mv squared over r, because those are the variables that I happen to have, so it makes it pretty handy to use that equation. All I have to do is plug in the numbers. The mass being 342 kilograms, the speed being 25 meters per second, and the radius being 126 meters. When I plug that into my calculator, I find that the centripetal force is 1696.4 newtons. Now we're going to solve for the normal force. In a vertical circular motion problem, any force that points towards the center of the circle is going to be positive. In this case, that's gravity. And any force that points away from the center of the circle is our negative force, and that, in this case, is the normal force. When you take all the forces that go into the circle and out of the circle and you add those together, what you get is the centripetal force. Now we just need to plug in some numbers, do a little bit of algebra, and we can solve. Now we're looking for normal force, so I'm going to rearrange this equation to get the normal force. And when I do that, I see that the normal force is equal to the force of gravity take away the centripetal force. Now, the reason why the normal force is going to be whatever gravity is minus the required centripetal force, that's because as a car goes over, or in this case a motorcycle goes over a hill, if you go too fast, you will, to use the phrase, catch air, so you will leave the surface of the hill. So the normal force actually gets smaller and smaller and smaller as you go faster and faster and faster over the hill until it gets so small that you've actually left the ground and it becomes zero. In this case, we haven't gone that fast, but we have gone fast enough that the normal force is equal to whatever gravity is minus the centripetal force, which is a bigger number the faster we go. So now we can plug in our numbers and solve. We know that the normal force is equal to gravity, which is mass of 342 kilograms, times 9.8 meters per second squared. And we solve for the centripetal force, which is 1696.4 newtons. And when I plug that into my calculator, I get that the normal force is 1,655.2 newtons. And now we're done.